chapter 6 today. We're starting section 6.1, angles of triangles. Our goal, students, will be able to classify triangles, that should say triangles, by sides and angles, which you've done this before. You did this back in elementary school, so we're going to go through that part kind of quickly. And then the new part, which is also done in middle school, you talk about the triangle sum theorem. Students will be able to find the measures of angles of triangles or angles associated with a triangle using triangle sum theorem and exterior angle theorem. Anytime you use triangle sum theorem, if you want to abbreviate that TST, that's fine. And if you ever want to abbreviate exterior angle theorem, EAT, that's also fine. And you're going to use those to find some missing angle measures. And some of them, it'll be really quick and you can see right away. But then others, it's going to take you a little bit because you got to go around and find this angle, so that way you can find this angle, and then you can find that angle. So it takes a few steps to get there. You will need two different colors of either markers, colored pencils, pens, highlighters. But you need at least two colors. If you don't have your own, you're welcome to come up and use some of mine. But if you go ahead and get those, please. You need two different colors. Like I say, you use highlighters, pens. Oh yeah, vocab. Once you get that, I need your chapter 6 vocab and your signed progress report. If you got your progress report signed, put it behind your vocab so no one sees it, and then pass your vocab to the front and to the right. So your signed progress report's due today, plus your chapter 6 vocab's due today. And your chapter 6 vocab is going to be page 26 in your binder. Chapter 6 vocab is page 26, and these new notes are page 27.
You're not messing stuff up. I just sorry.
Yeah, don't forget to put up your phone and smartwatch.
I have another one.
Alright, so chapter 6 vocab. I need your chapter 6 vocab and your signed progress reports. Get those out. Make sure your name's on them. Pass them to the front row, pass them to the right. Put your progress report behind the vocab. Yes, some people will turn theirs in. So chapter 6 vocab and your signed progress report. Your chapter 6 vocab is page 26 of your binder. Your 6.1 notes is page 27 of your binder.
We're at table country.
Do what?
Our table of country is back.
There's a back page. Alright, does anyone else have vocab or a signed progress report to turn in? Alright, now let's get started. Alright, so what exactly is a triangle? A triangle is a polygon that has 3 sides, which means it also has 3 angles. Okay? Now, there are different types of triangles based on the length of their sides and the measure of their angles. Bless you. So first we're going to talk about classifying triangles based on the measurement of their sides. Alright, so first is a scalene triangle. So over there under teacher notes where you see scalene triangle, I need you to write the definition of scalene triangle, which is no congruent sides. No congruent sides. That means none of the sides measure the same length. All 3 sides are different lengths. That's a scalene. No congruent sides. Alright, and then if you look over there on the right side, there are 3 triangles. Which of those triangles would be a scalene triangle? Yeah, the first one. So label that first one as a scalene triangle over there on the right. So that first triangle is scalene. That's because all three sides are different lengths. None of the sides are the same length. Alright, the second type of triangle is an isosceles triangle. An isosceles triangle, the definition that you're going to write over there on the left, says it has at least two congruent sides. At least two congruent sides. At least two means two or more, which there's only three sides, so two or three sides, if they're not congruent, it's considered isosceles. So an isosceles triangle has at least two congruent sides. Which of those triangles over there on those top three triangles would be considered isosceles? The second one? Yeah, it's not got two sides the same length. How did you know? Yeah, it's got the lines on there showing it's congruent.
What was the scaling definition again?
No congruent sides. Is there another isosceles triangle over there? Yeah, the third one's also isosceles because it has three congruent sides. And as long as it has two or more, it's isosceles. So the second and third triangle would be isosceles. So the first one's scalene and the second one and third one are isosceles. Alright, the next type of triangle is equilateral. Equal, lateral means sides, equal sides. Equilateral triangles have three congruent sides. Okay, so write that definition down over there under equilateral. Three congruent sides. So equilateral has three congruent sides. So scalene has 0. Isosceles has 2 or more. Equilateral has 3. So over there are those top three triangles. Are any of those equilateral? The third one. So the third one's isosceles and equilateral. But on an assignment like Big Ideas Math, you're going to want to say it's equilateral.
So,
If you put isosceles and equilateral, I mean, that's correct. But just know on Big Ideas, it might count you wrong if you call it isosceles. But technically it is. If you wrote isosceles on a test or a quiz or an assignment, I would count it right. But it is, the more formal name for it is equilateral. Alright, classifying it by angles. Classifying triangles by angles. The first one, oops.
So I should take my phone book home tonight.
Probably. Yeah, take your Chromebook home every night, just in case. Because you never know. Because even though the weather might not be bad, it could be something else.
Yeah, I could sleep in the truck.
I wouldn't do that. It might get too cold myself. Alright, an acute triangle. An acute triangle has 3 acute angles. An acute triangle has 3 acute angles. So write that down over there on the definition. An acute triangle has 3 acute angles. What does acute mean?
It's got 3 angles.
I'm sorry, I only heard the 3 angles. What does acute mean?
Less than 90.
Less than 90 degrees. So all of the angles are less than 90. All of the angles are less than a right angle. They're smaller than a right angle. So notice all 3 angles are acute. Look at those bottom 4 triangles. Which of those would you consider acute?
First one, the first one.
Yeah, the first one, the one on the top left. So label that one as acute. On the top left at the bottom 4. Yep, so that one right there would be acute. Is there another acute angle?
No. Yeah. The bottom right one. Fourth one.
The second one.
Second one.
Yeah, the second one.
The second one on the top. The second one on the top. That one's also acute. None of those angles are bigger than 90. None of them are 90. They're all less than 90. So the top 2 would be acute. So label that one as acute also.
Going on speed.
Yes.
It doesn't get 90 and going on.
Alright, another type of triangle is a right triangle, and it has 1 right angle. Notice it can only have 1 right angle. So a right triangle has 1 right angle, and which of those triangles would you consider a right triangle? Yeah, the third one or the first one on the bottom, the one on the left, bottom left, that's a right triangle. One of its angles is 90 degrees. And then you have an obtuse triangle. Obtuse triangle says one obtuse angle. You can't have more than one. You can't have less than one. You can only have one. An obtuse triangle has an obtuse angle. What's an obtuse angle?
Angle above 180.
Not above 180.
Above 90.
Angle above 90. So if you look here at this angle right here, we can tell that that's bigger than 90. So that's an obtuse triangle. So which of those triangles on your paper is obtuse?
The bottom right one.
The bottom on the right, the fourth one is obtuse. So the two at the top are acute. The one bottom left is right. The one bottom right is obtuse. And then there's one more. I don't know why it always skips it too. Equiangular. Equilateral means equal sides. Equiangular means equal angles. And equiangular has 3 congruent angles. Equiangular has 3 congruent angles. And which of those triangles over there are equiangular?
The second one. The second one.
Yeah, the second one on top. The one on the top right, equiangular. How could you tell that all 3 angles were the same without measuring them?
So you got that line there?
Yeah, they're all marked congruent. They have these arcs that mark them congruent. Now, your book wants you to actually take a protractor and a ruler and like measure the angles, measure the sides. If they're going to be congruent, you can pretty much tell. It's got the arcs on them showing, or the lines showing that they're congruent. If it's a right angle, it's going to be marked as a right angle, and if the sides are congruent, the sides are going to be marked congruent. So we need to be able to, if they're not marked, then they're not congruent. All right, so now let's do an example. Classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. So first I want to do the sides. Well, mine is, it's colored so you can see it a little bit better. But this triangle made out here with the support beams, and it's got this one and this one marked as congruent. So it's got 2 sides marked congruent. Well, from previously, it says if it has at least 2 sides congruent, that would be considered isosceles. So I would classify it as isosceles by its sides. Okay. And then by the angles, I would look to see if any of them are right, obtuse, or marked congruent, and none of them are marked. So what we would do is, I would look to see they're all less than 90, so that would be considered acute. So it's an isosceles acute triangle.
How do you know that some people are angular?
It could be if I used a protractor. Well, it's not marked for me. They would need to be marked for me. But I could use a protractor to measure them to see if they're equiangular, because they do kind of look equiangular, but I'm not completely sure. So I couldn't say that unless I was completely sure. But if you were to use a protractor and find that all 3 of these were the same, then you could. All right, this one here. Classify the triangle by its sides and by measuring its angles. So with its sides, you want to look to see if any are marked congruent. Ivy, how many sides are there any sides marked congruent? If so, how many? Yeah, there's 2 sides that are marked congruent. So John, what would we consider that one? Isosceles, perfect. And then you look at its angles and you see if there's a right angle, an obtuse, an acute, or if they're all 3 marked congruent. Kaden, what kind of markings do you see on the angles? There's a 90-degree angle. All right, so Gabby, so what does that mean? What type of triangle is this? Right. Perfect. It's a right triangle because it has that right angle right there. So this is an isosceles right triangle.
It's almost summertime.
All right, here's another one. Classify the triangle by its sides and by measuring its angles. Okay, so first let's do it by its sides. So you want to look to see how many sides are marked congruent. Ben, how many sides do you see marked congruent? 3. Alright, Braxton, what type of triangle has 3 congruent sides?
Angular triangle? No, hold on. Okay. I'm an idiot. Equilateral.
Equilateral, perfect. Equilateral
I
means
meant
equal
that,
sides.
the other one looks the same.
You're saying the angles look the same?
No, the word.
Oh, yes, the words do look
So I
the
just
same.
glanced at it. I can spell it, I promise.
Alright, so equilateral, all 3 sides are marked congruent. Alright, Andrew, what would you add to or what would you say about its angles? What type of triangle is it based on its angles?
Acute because they're not marked. Congruent.
Yeah, if they're acute, they're not marked congruent. Now, I will tell you that in another section later on, we will talk about the base angles theorem and the corollary to the base angles theorem. In an isosceles triangle, if the 2 sides are congruent, then the 2 base angles are congruent. So these 2 sides are congruent means these 2 angles are. And then if these 2 sides are congruent, these 2 angles are congruent. So technically, this would also be equiangular, but we just don't know that yet until another section. But so you could call it equiangular. There's something else you could call it too. What's another name you could do on this one, based on its sides? Not only is it equilateral, it's also something else. Yeah, it's also isosceles. So these you could consider either isosceles or equilateral, and then based on the angles, you could either say acute or equiangular. Like I said, we haven't talked about the base angles theorem or the corollary to the base angles theorem, so you may not have known that just yet. Alright, chunk 2, interior angles. Here's what you needed the 2 different colors for. So what I need you to do over on chunk 2 on teacher notes is under interior angles, I need you to write the definition as the original angles of a triangle. Interior angles are the original angles of a triangle. So the interior are the original angles. And then over there with your colored pencil or marker or colored pen, I need you to color in the 3 interior angles of that top triangle. Here, mine looks a tad bit different than yours, but here's angle A, angle B, and angle C. You color in the inside 3 angles. Those are the interior angles.
There's a snake on the board.
There was drawings on it when they brought it to me.
What's that messed up going with your well? What's that messed up going? I think that was Miss Pepper's.
I'm sorry to get out for 1 minute.
Puerto Rico.
Alright, the other thing is exterior angles. I want you to color those a different color, and I've got another picture. Okay, so for the definition of exterior angles, you need to write the angles that form linear pairs with the interior angles. The angles that form linear pairs with the interior angles. Remember, a linear pair are 2 adjacent angles side by side that make a straight line. They add up to 180. And then on your picture, I need you to color the linear angles, the exterior angles a different color than what you did the interior. So if you did your interior as red,
Oh crap, that's the wrong picture.
it would look like this. So the red angles are my interior angles, and the blue angles are my exterior. So if you were to extend one of the sides, it would be the angle that forms a linear pair with the inside angle. A linear pair means they're right next to each other and they add up to 180. They're adjacent and supplementary. Okay, so hopefully this is what your picture looks like on the top. You might not have used red and blue. And I just want to show you, at each, depending on which sides that you extend, you could have 2 different exterior angles. let me do this. Okay, so if you look right here at this triangle on this page, see here angle, this angle B. If I were to extend this side, this angle here would be the exterior angle. And these two would be supplementary. They would add up to 180. Well, if I extended this side, this would be my exterior angle. So notice there could be two different exterior angles at each one depending on which side you extend. And then we also have this angle right here. What type of relationship do these two red angles?
Corresponding.
They're not corresponding. Corresponding is when you have parallel lines and they're in the same spot. They're across from each other.
Vertical angles.
Vertical angles. And vertical angles are congruent. You're going to be using that a lot today on your assignments.
You're welcome. Thank you.
Alright, so there's your picture. Okay, so now that we talked about interior and exterior angles, here's your triangle sum theorem. You need to write what it says down on the left first. So what the triangle sum theorem says is the sum, which means to add, of the measures of the interior angles of a triangle is 180 degrees. Okay, so write this definition for triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. Okay, and then over there on the picture, under triangle sum theorem, I need you to write this formula. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees.
Where we write that?
Over on the right underneath the picture, underneath triangle sum theorem, you need to write the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees.
Is that supposed to study? I just want to ice.
Alright, so what this means is this is only for interior angles. So that means if I were to take this measure and add it to this measure and add it to this measure, they would all three equal 180. So like if this one was 40 and this one was 30, that's 70. This one would have to be 110 in order to make it 180 degrees. Okay. Now the other theorem says, the exterior angle theorem says, I'll let you write this down before I explain it. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent, that means it's not right next to it, interior angles. So write that under the definition of the exterior angle theorem. And then after you do that, go over to the right side underneath the picture and write the formula. The measure of angle 1 equals the measure of angle A plus the measure of angle B. Alright, so to put this into numbers, make a little bit more sense. Let's say this interior angle here at C is 40 degrees. 40 degrees. Well, these two with the exterior angle form a linear pair, which means they add up to 180. So if this one's 40, how much is this exterior angle going to have to be? Okay, so,
140.
yeah, 140 degrees, because they're a linear pair and they have to add up to 180. Well, 140 plus 40 is 180. Well, not only do these two have to add up to 180, but all three of these have to add up to 180. So if this one's 40, how much is A and B gonna have to add up to be? If they all three have to add up to 180. They're gonna have to add up to be 140. Like this one could be 50, that one could be 90, this one could be 60, that one could be 80. But whatever they are, they have to add up to 140 because all three have to add up to 180. Well, since that's the case, this one has to add up to or these two have to add up to equal the exterior angle. So that's what that means. And that's why it does. Alright, so let me show you an example. I'm going to do an example, one with triangle sum theorem and one with exterior angle theorem. It says find the measure of angle 1, then classify the triangle by its angles. Okay? So I noticed this is 78, this is 31, and this is 1. And I noticed that all three of these are interior angles. And it's very important to pay attention to if you're talking about an interior or exterior. So they're all three interior, so I'm going to use the triangle sum theorem, which says that all three add up to equal 180 degrees. Okay? Well, this is 78 and this is 31, and I need to see how much do I need to add to that to make it 180. So to do that, I would do 78 plus 31 to see what they add up to already. 8 plus 1 is 9, 7 plus 3 is 10. So these two angles add up to 109 degrees. Well, I need them to add up to 180. So what I would do is do 180 minus what I already have, which is 109. 10 minus 9 is 1, 7, 71 degrees. So I need 71 more degrees to make it 180. So that means the measure of angle 1 is 71 degrees. Okay, that's this angle right here. Okay, then it says you need to classify by its angles. So it can either be acute, right, obtuse, or equiangular. Well, it's not equiangular because they're not all three the same. It's not obtuse because none of them are bigger than 90. It's not right because none of them are 90. So that would have us left with acute. So this triangle is acute. Okay. Then I have a teacher example with exterior angle theorem. It says find the measure of the exterior angle. So they're wanting me to find the measure of this exterior angle here. Well, I know from EAT that the measure of angle 2 is going to be these two here added together. So I add together 75 plus 64. 5 plus 4 is 9. 7 plus 6 is 13. So the measure of angle 2 is 139 degrees. And if it were to tell me to classify it, I would need to find this angle measure. 180 minus 139 would be 41. And they're all acute, so it would be an acute triangle. But it didn't ask me that, so I don't need it. Alright, what questions do you have for me before we try one together? Okay, let's try this one. I noticed it says find the measure of the indicated angle, and I know it doesn't say it, but let's classify it also once we're done. So this interior angle is 20, this interior angle is 130, and I need to find this interior angle. Okay. Which theorem would I use? The triangle sum theorem or the exterior angle theorem?
Triangle sum theorem.
Yeah, and what does the triangle sum theorem say again, Colton? Alright, well, you should have it written down right there on chunk 2. So go back to chunk 2 at the beginning, and it says triangle sum theorem. And tell me what triangle sum theorem says.
Some measures of the triangle.
Okay, so sum means to add. So that means if you added 130 plus 20 plus whatever this is, you should get 180. Well, somehow I've got to figure out what is missing. John, how would I go about doing that? What would I do first?
You add on 1 to put everything
Okay, so I add 130 plus 20, and make sure that that's a 20, because I can only halfway see. All right, so it's 150 degrees. All right, what would I do next? They have to add up to 180, and these two only add up to 150. Aiden, what would be my next step?
Subtract, 20, no, 180.
And what do I get for that angle measure? 30 degrees. All right, so this angle right here would be 30 degrees. It would have to be in order for them to all three add up to 180. All right, so my next question, what type of triangle is this, Rayleigh? Based on its angles. You've got acute, right, obtuse, and equiangular. Okay, how come it's a right triangle? It has one right angle? Okay, a right angle means it equals 90. Which of these is 90? Obtuse, why is it obtuse? Yeah, one of the angles is bigger than 90, which is this one here. So since that one's bigger than 90, it would be considered obtuse. All right, very good. All right, here's the next one. This is one of those where you're going to have to use multiple things in order to figure out the angle measure. It says find the measure of the indicated angle. And you've got this angle here is the one they're wanting. Well, you've got this angle that's 102 degrees, and then you got this exterior angle that's 137. All right, Ivy, this angle here that they're wanting, is it an exterior angle or an interior? It's exterior, so this one equals these two added together. But I don't know what this one is. How can I go about figuring out this angle up here?
180 minus 137.
Why?
Because it's a straight line.
Yeah, these two are a linear pair, which means they add up to 180. So to figure out this angle, you would do 180 minus 137. 8, 7, 10, that's 43 degrees. So this angle right here is 43 degrees. Now I can use exterior angle theorem because this one's going to equal these two added together. All right, Gabby, what do you get when you do 102 plus 43? 145 degrees. So that means this angle here is 145 degrees.
We did it.
All right, what questions do you have for me? You are going to do the next two with your partner. Notice you're going to have to use some theorems from previous chapters from at the beginning of the year. You need to do numbers, the last two problems with your partner, and make sure and explain to your partner how you got your answers and why, because some people can like see it and know right away, and others can't really see it right away. It takes a little bit for them to see it. All right, turn your desk and face your partner.